let's again keep a bird's eye view of what we're doing in our analysis. So we've seen this thought process before. We've discussed it. We've discussed these steps. So we have trained our model. We have a decision tree model. We're using default values and we have predictions. But now we're in this step. We're trying to evaluate and understand the predictions and how to improve our model. So now we're fine-tuning. We have evaluated the model in cross-validation as one of the methods. We'll look at other methods in the coming videos. But now let's fine-tune our model and see how we can improve our results. So we have the decision tree classifier. So you've seen this. So these are all the default values, and again, you can go to the scikit-learn website and see a detailed description of all these parameters. We have, so we're still on that on that step where we have the default values, and if you run this, you see that we're still using all the default values. And now let's go step by step and discuss how we can change these. What are these parameters? So we're gonna fine-tune a subset of these parameters, and these are highlighted over here. And as a first step, as you gain more experience, you'll see that these are the parameters that are typically tuned as a first step in decision trees. So the criterion for the split, right, we've discussed is either Gini or entropy. So this is just a measure of the impurity or the purity of a split, right? And the max depth, right? The max depth is the maximum depth of a tree. And so the example that's shown over here, right? You can see that this tree has a maximum depth of 1, 2, and 3. So this is going to be the maximum depth. So if you limit the maximum depth to, let's say, 2, it's going to stop over here. But if you let it change it to 3, it's going to go and split this node further. And so if you leave it to the default values, it's just gonna grow your tree as much as possible. And so if you leave the default value, you're most likely going to overfit, right? And that's what's happening in our result, that it's we have a lower accuracy because we're most likely overfitting with all the default values. So again, if you have a tree that's really deep, you're going to overfit. But if you make it, if this parameter is really small, you're going to underfit, right? So you want to have a value that's somewhere in between, right? Okay, let's look at the minimum samples split. So this is the minimum number of samples required to split an internal node. So we've discussed this example, so this is just like a review of what we did, right? For the decision tree introduction, we've discussed this example. So these are, and the reason I'm showing these is because just to make sure you know what these definitions are. This is an internal node, right? So these parameters are gonna sometimes split, put a constraint on the internal node or the leaf node. So this parameter, minimum sample split, is for an internal node. So if you require a particular number of samples, a minimum number of samples for a split on an internal node, then you would change this parameter. And the default value is 2. And so this is, let's say, an internal node over here, and we have a split taking place over here, right? So this internal node has 4 samples. So two samples over here, that you get a further split, 2 over here, and then this internal node has 5 samples in total, and 2 go over here and 3 end up on this side. So if we, let's say, limit our if you limit this parameter to 5, let's say, then this node will not split because this has 4 samples, right? But this node has 5 samples, and this will further split. Okay, so let's go to the next parameter, that's minimum samples leaf. Now, just make sure you understand, so some people typically get confused on these two parameters. This is for an internal node and this is for a leaf node. So again, this is the minimum number of samples required to be at a leaf node. Leaf is, again, let's go back, leaf is where you stop, right? So how many samples do you want, how many minimum number of samples you want at a leaf node? And so let's say that default value is 1, right? This leaf node has 2 samples, this one has 2, this one has 2, this one has 3, right? So the tree will keep on splitting until the leaf node has 1 sample. And again, we are gonna tune this parameter as well. The last one we'll tune is the max features. So again, this is the maximum number of features to consider for the best split. Now, this is the tree that we discussed in the example, but with the split not done yet, right? So when a split is done, right, so you can see that we have 3 features over here, right? How many features should the model consider in order to do the next split, right? So this data set just had 3 features. So data sets can have any number of features, right? So how many features do you want the algorithm to consider in order to make the best split? And so this is the last parameter that we're going to tune. Let's go to the program and see what possible choice of these values result in an improved accuracy of our model.